Hello, welcome to Einstein Mechanics. In this episode, we are going to talk about the superposition theorem, one of the theorems that help us to analyze current through a particular active element. In the superposition theorem, we are going to have two or more current or voltage source. And what we are going to do here is anytime we are going to work at a particular instant, we are going to have only one active source. So at any instant of analysis, we are going to have one active source, so that if there are three sources, being it current, voltage, we are going to perform three analysis. You'll get to understand. And you have to pay attention to this information. We are always going to short circuit a voltage source, and we are going to open circuit a current source. So meaning when we have a current source that we are not performing analysis at the instant, we are going to open circuit that current source and we perform our analysis. So let's look at this diagram and make some deductions out of it. So we have our resistors. This is my current source. I will also have a resistor here. I have my voltage source. So this is my circuit. I'll call the resistor R1, R2, and I'll call this as my I for the current source, and I'll call this R3. This is my voltage source V1. So when you look at this circuit, we have voltage source 1, we have current source 2. So we are having two sources. And what the superposition theorem is telling us is at any instant we should perform analysis and find current with only one of the sources. So here, my first analysis, I'm going to consider the voltage source. So in this case, I'm going to open circuit the current source, meaning current is not going to pass through that, and this is going to be my diagram for analysis. So I still have my voltage source intact. I have my resistor 1. I'm going to have my resistor 2. Now, the current source is opened, so no current, so we can ignore it. And I have my resistor 3. So this is the circuit for the first analysis, say R3 and R2. In this circuit, we are to find current through the R2 resistor. So in such case, we are going to distribute the current, say I, and we know this I is going to split into I1 and I2. So considering this voltage source acting alone, we have this circuit. And how do we have or distribute current so that we can know the current through the two resistor, the resistor 2? First, we have to find the total resistance in the circuit. The total resistance. Please pay attention. We have to pay or find for the total resistance in the circuit such that we apply the Ohm's law, which says V is IR, and this current, the entire current produced by the voltage source V1, can be known by dividing the voltage by the total resistance. So we are going to get our current I. And if we have our current I, then we can also apply the current divider rule at this junction, because we know that this I is passing through the resistor 1. Everything is passing through. So at the junction, it is going to split into two, I1 and I2. And by the current divider rule, if we are finding current through the resistor 2, that is going to be I2 will be resistor 3 on resistor 2 plus resistor 3 times the current I. And with this, we are going to get I2 as something amperes. And with this, this is the current passing through the R2 when the voltage source is acting alone. So we will now also consider the current source acting alone. Consider I acting alone. So it is very simple. So here too, we are going to short circuit the voltage source and work with the current source. This is going to be my diagram. So short circuit this part. I have my resistor 1. I have resistor 2. This is my current source. And I have resistor 3 in position. So this is going to be my circuit. Resistor 1, resistor 2, I have my I, and resistor 3. So with this circuit, we are going to perform analysis to know the current going to pass through this resistor 2. What we know, this current I is also going to split itself into two. At this junction, we have IA and IB. Are we okay? So now we also have to combine the effect of these two resistors such that we will know the current going to distribute among them. So we can see that R1 is also parallel to R2. Are we okay? So once we get that, we are going to get their effect as, say, RB for the parallel arrangement of R1 and R2. Now, this is going to be the diagram. We are going to have, this is our RB from the effect of R1 and R2. And this is going to be our current source. And this is still going to be our R3 this way. So now we have this, still this is current IB, still this is current IA. Now we have R3 and RB. We can use the current divider rule to find the current IB passing through resistor RB. Are we okay? So that will be RB, or the first current going to pass through RB is IB. And by the current divider rule, we are going to get R3 on R3 plus RB multiplying the current source I. The value of the current source is going to be given. So now we are going to know the value of IB going to be distributed among R1 and R2. Now, if we have the value of IB, we can still use the current divider rule again to find the current, because this RB is the total effect of R1 and R2. So we can also, from this first diagram, apply the current divider rule to know the current going through R2 and R1, and that is going to be, say, this current RB is going to divide itself into I prime and the one here as I prime prime. So meaning our I prime is also going to be, now we'll consider resistor 1 on resistor 1 plus resistor 2 multiplying the current IB. And with that, we will also know the value of the current passing through our R2. Please take note, now we have two currents, I1 or I prime, and we also have I2. So what matters here is direction. From the first diagram, when we consider the V1 acting alone, you can see that your I2 is moving downwards. Your I2 current is moving downwards through the R2. It is moving downwards through the R2. So the current we got is going to move downwards. Now, when you consider the current source acting alone, which is the I, what you are going to see is that the current passing through the R2 is also moving upwards. That is our I prime. It is moving upwards. So our current we are getting here, something amperes, is upwards. So here you are going to find the total current passing through R2 by the algebraic sum of whatever you got here plus whatever you got here. But the direction matters. You consider which direction you want positive, which direction you want negative. So with that, you can find the current so simple. Let's look at an example to validate our analysis. It is very simple. Now we have example. Find the current through the 2 ohm resistor. Now we have our circuit. We are to find the current through this 2 ohm resistor using the superposition theorem. So right away, we identify the sources that we have. How many sources do we have? We have one voltage source, we have a current source. So meaning we are going to perform two analysis. By first, I'm going to deactivate the voltage source and work with the current source. So let's look at how best it goes. So this, I'm going to let my solution, let the 6 ampere act alone. So in this case, I'm going to deactivate the voltage source. So this is going to be my diagram. I'm still going to have the voltage source working. My resistor 3 ohms is working. I have my resistor 4 ohm working, and I'm having the 2 ohm resistor, the 5 ohm resistor, and the 6 ohm resistor. Now the voltage source is short circuited, so we have our diagram this way for the circuits. This is 3 ohms, 4 ohms, this is 2 ohms, and our 5 ohms, 6 ohms. So now we have the current 6 amperes. How do we manage to find current through the 2 ohm resistor? Before we can do that, we have to find the effect of the resistors. First, let's combine the effect of these resistors, and they are parallel resistors. So you can see that the 5 ohm resistor is parallel to the 6 ohm resistor, and that is going to give us a total resistance of 5 multiplying 6 and 6 plus 5. That's the inverse rule will also work. So we are going to get 2.72 ohms. So this is the effect of the 5 ohm and the 6 ohm. So now our circuit is going to be reduced to this form. Now the current source is still there. We are going to have the 3 ohm resistor. I'm going to have my 4 ohm resistor, and this 2 ohm resistor is going to be in series with the effect from resistor 6 ohm and resistor 5 ohm. So this is my circuit. So this is the 2.72 ohms. This is still my 2 ohms, and this is 4 ohms. This is 3 ohms, and the current source is 6 amperes. Please pay attention. So now we have this current moving. So this current is going to divide itself into two, where we have I2, and I'll call this I1. Now we can use the current divider to also find the current passing through that. So with the help of the current divider, we are going to find I2. Remember, I2 is moving this way and I1 is moving this direction. So it will first pass through the 2 ohm. Everything I2 will first pass through the 2 ohms that we are interested before it splits itself among these parts. So our focus is on I2. So by the current divider rule, I2 is going to be, this is the resistor in parallel with the interested resistor. So that will be 4 on our 4 plus 2 plus this resistor, which is 2.72. You can check out for the current divider rule to understand it very well. And the total current coming is 6 amperes. So with this, our I2 is going to be 2.75 amperes. But the direction of current when the 6 amperes is acting alone is in this direction. So now we have the current passing through the 2 ohm resistor when the current source is acting alone. So let's try that for the voltage source, which is the 24 volts acting alone. So now let's the 24 volts act alone. So we have the 24 acting alone. We have to draw our circuit. And if the 24 is going to act alone, we are going to open circuit the current source. So let's pay attention here. Imagine this current source is opened. It is going to be opened. And let's check from the second diagram. It is going to be open, so meaning it is open this way. And we have our voltage source also active this way as our 24. Now, what do you see? If this current coming gets to this direction, because it is open and there's no flow, everything now will pass through the 4, meaning this 3 ohm resistor is going to be of no use. Are we okay? So meaning opened circuit for the current source is going to render this resistor to be of no use. So this is what our diagram is going to be like. It is going to have the 4 ohm resistor. It is going to have the 2 ohm resistor. We are going to have the 6 ohm resistor. We have this 5, and this is going to be our voltage source. So this is going to be our diagram. So this is the 24, this is the 6 ohm, we have 5 ohm, this is our 2 ohm, and this is the 4 ohm resistor when the 24 volts is acting alone. And if it is acting alone, it is going to produce a current I, because this is the positive side. It is going to produce a current I, and we are going to see that this I is also going to distribute itself between these branches. Now we have to find the current I. What is the total current being produced by this 24 volt source? So with that, we have to find the total resistance in the circuit and use Ohm's law to find the current produced by the voltage source. Is that right? So finding the total resistance in this circuit, we are going to see that this 4 and 2 ohm, they are in series, so they are going to add. So the 4 ohm plus the 2 ohm resistor, it is going to be parallel to this 5 ohm. It is parallel to the 5 ohm. Are we okay? And everything that we are going to have from this analysis is also going to be in series with the 6 ohm. So that is going to be plus the 6 ohm, and that is going to be our total resistance. So that is going to be the addition of this, that is 6 ohm parallel to the 5 ohm, and this is also going to be in series to the 6 ohm. You can also use your normal analysis to find the total resistance. So this is going to be 6 by 5 on 6 plus 5. The parallel aspect going to be added to 6 to get our total resistance. And from the analysis, our total resistance in the circuit is going to give us RT 8.727 ohm from the circuit. Are we okay? So now we have the voltage, we also have the total resistance in the circuit, meaning we can find the current I produced by the voltage source. So let's look at that. So we are going to use that idea to find the current. So from Ohm's law, the current produced by the 24-volt source is going to be I V on R, and that is going to be 24 divided by the total resistance 8.727, and the total current is going to be 2.75 amperes. So now from this diagram, when the 24 is acting alone, the current I is giving us 2.75. So at this junction, it is going to split itself. So we can use the current divider rule to also find the current passing through the 2 ohm. Remember, the same current is going to pass through the 4 because they are in series. And by current divider, let's call this current, the first one is called, we got I2 when the current source is acting alone. So I will call this current as I prime. So I prime is going to be by current divider 5, the 5 ohm resistor on 5 plus the 2 plus the 4 ohm, multiplying the total current coming. That is going to be 2.75, and that is going to give me 1.25 amperes. What's the direction? When you look at the direction of the current produced by the 24 ohm, it is in this direction. So now we have the current produced by the voltage source through the 2 ohm. We also have the current by the current source through the 2 ohm. So one is to the positive side of the x-axis and one is to the negative side. So it is up to us to choose our direction. So now our current through the 2 ohm, as the question demands, is going to be, I'll choose the one to the positive side as positive. That is going to be positive 2.75, and choose this as negative 1.25. So the total current is now going to be 1.5 amperes through the 2 ohms, and the effect is going to be this direction, because this direction is the positive one and we are getting a positive answer. Thank you for watching this episode. It is very simple to do the analysis for superposition theorem. Check out for the next episode. We have 2 more examples to solve. See you in the next episode. Kindly subscribe to the channel, drop your comments, like the video, and share the video.